Okay, I'm going to go over the error propagation calculator that I wrote. You're going to need Mathematica or the CDF Player Pro. I tried to make it for the free version, but the program requires text input, which is only available in the Pro versions. So here we go. First, you're going to unzip the error calculator, open the file. It comes with some documentation that you should read, as well as a link to the example problem that I've done. And it comes also with some screenshots that you can use to kind of guide you through as you do it yourself. Okay, so let's get started. You're going to open it up, enable dynamics, and then you're going to write the variables that you have uncertainties for, and then the function that's used to calculate the result. And as you change it, if you hit enter, the uncertainty down here will also update. And so this is the first example that we're going to do. So you can copy the result, and then if you copy as mathml, you'll be able to paste this into a Word document, which is super slick. You won't have to worry about any of the formatting or anything like that. Okay, so copy, paste. And then if you substitute in all the variables, you can solve numerically also. One issue that this does have is that these are subscripts, and if you try to just do it normally without changing them, it'll actually change the subscript to the value of the subscripted value, I guess. So you'll have u sub 50, but you don't want that. So what I always do is I change this to actual um instead of u subscript m and like that. And then it'll work out just fine. So you'll have 0.097. If you check the documentation, they also got 0.097, so that checks out. And then if you want the solution for the actual acceleration, you can just copy the function, paste the function, and then delete the quotation marks, and execute again. To execute, you're going to have to hold down Shift and then hit return. That's because in Mathematica, a return is actually just a space, so you can add more code without executing. So make sure you remember that. That's a little tricky when you first get started. Okay. And then if you want to paste this whole thing in, you can do, or if you want to write what this is equal to, rather, you can do subscript, uncertainty, A, copy as mathml. I always forget to do that. And then you have a nicely formatted whatever equation that you can use in a report. Okay, second example. The damped natural frequency. So let's start. So to do Greek letters, you just do these two characters, type it in, and then close bracket. And then you'll likely get some errors when you click to the other part. Just ignore them and keep chugging along. Doing Control 2 will do a writ for you. Zeta, and then Control 6 will do power. Hit enter, and then you'll have the uncertainty function. You can just delete these over here. Delete. One thing that you should note is not to use the subscripts in these boxes. Like over here, it's W or omega sub n. I don't use the actual n's, I just substitute them in later because, again, they'll just cause errors. So try to avoid that if you can. Copy as mathml, paste it in here. There we go. And then I want to replace the omegas with omega n's, so it's not confusing. Make sure to copy as mathml again. And then we'll grab this. Oops. Don't know why it's doing that. There we go. So hopefully that helps, and you're able to improve your reports and actually do the error propagation. I know a lot of people don't do it, but it's really not that bad, especially with the use of some symbolic error propagation stuff like this. If you're curious about the like kind of what's going on under the hood over here, I basically just implemented this equation for error propagation. You can find it on the Propagation of Uncertainty Wikipedia page. Just scroll down, and it's this one. It's really not that complicated, but people still fail to do it. So hopefully this helps. Thanks for watching. Like, comment, subscribe, all that stuff. If you have any concerns, you can try messaging me on the YouTube page. Thanks.